A comparison between mechanical fastening and bonding method and PSAs in industrial application. The pros and cons. Mechanical engineering solutions, fasteners, nut bolts, nails, staples, screws, tabs, posts, rivets, welds and shoulders. Chemical engineering solutions, hot melt adhesives, spray adhesives, liquid adhesives, pressure sensitive adhesives. The main considerations, other factors, performance and durability, cost of raw material, labor, tooling, manufacturing productivity, maintenance and serviceability, availability, functionality, bonding strength. Comparison chart for mechanical fastening and bonding methods and PSS. Here is the chart showing a comparison between radial riveting, clinching, self-piercing or riveting, screws, bolts, fastening, spot welding, adhesive bonding, and PSA bonding. And the comparison is done for properties like corrosion, joint point alteration, dynamic load, crush load, static load, edges, burring or splinters, consumables, energy, and material. Here is another chart giving a comparison of the various methods like riveting, clenching, self-piercing riveting, screw nut bolt fastening, spot welding, adhesive bonding, and PSA bonding with environmental friendliness, handling, reproducibility, dependence of joint results and surface quality, pre-processing, joining different materials, joining single components, investments, assembly, flexibility. Mechanical fasteners, bolts, screws, rivets, staples, tabs, posts, and nuts attach or join components. Device inserted to hold material or substrate in place. Advantages, fairly easy application, low capital for equipment needed to apply normal labor and provides good product aesthetics. Disadvantages are higher component costs, prefabricated fasteners inventory, smaller contact limits bond to materials, load performance, prone to loosening, weakening, rusting, noise source, hot melt adhesives, EVA-based materials applied as molten substrate and form a bond when cooled. Bond achieved by applying adhesive in beads or square on the substrate. Advantages, inexpensive, low raw material cost. Disadvantages, constant inspection by user to ensure quality, that labor. Equipment to melt and deliver adhesive is needed. Difficult to apply adhesives to very edge of the part. Higher capital and maintenance. Performance impacted by time between application of adhesive on one substrate until contact to second substrate performance, liquid and spray adhesives, solvent-based emulsion epoxies or acrylates applied via air pressure mist or dispensing applicator, a brush, or roller coating. Additional equipment may be required to activate curing to set and establish the bond, may or may not be tacky to touch after drying. Upon application of adhesive, second substrate can be bonded. Advantages: inexpensive, low material cost, can achieve 100% coverage. Disadvantages: overspraying, difficult to limit the specific areas, high capital for application equipment, maintenance, labor intensive in use, environmental and regulatory processes implications, solvents may be subject to labor intensive cleanup, pressure sensitive adhesives supplied on a web stock. PSS can cover a wide range of performance characteristics and properties for specific applications: single coated tape, double coated transfer adhesive, adhesive sandwich. Advantages: minimal capital cost to apply on substrate, provides 100% coverage for optimal addition to bonding, can shorten assembly time and reduce labor needed. Productivity. Disadvantages: PSS range from $1 per square inch to $25 per square inch, that is the raw material cost. Pressure sensitive adhesives, a term designating a distinct category of adhesives that in dry form are aggressive and permanently tacky at room temperature, will adhere to a variety of substrates when applied with pressure, do not require activation by water, solvent, or heat, have sufficient cohesive strength so that they can be handled with fingers. Drivers for PSA growth: total cost of ownership, adhesion bonding performance, aesthetics, material compatibility, lightweight properties, barrier properties, sound and vibration control, low surface energy uses, constant adhesive coating application, flexible market applications. Markets like automobile, aircraft, building and construction, HVAC, general industrial, electronics and appliances. Application factors: PSA selection. The selection of the product for an application requires as much details about the needs of both the converter and the end user as possible. Satisfaction of end use requirements without addressing concerns or processing the material does not ensure successful use of the product. Identifying the range of needs as early as possible improves the ability to address requirements in the processing and application stages. Application factors which should be considered: these are price target, expected usage, that is the volume, timing of project, material to be joined, how will the product be processed, migratory components of the substrate, life expectancy of the product, existing specifications, previous problems encountered, how the product is applied, conditions of substrates, what does the tape have to do? What does the tape have to do? Texture of substrate, temperature at application, temperature during use, exposure to UV, exposure to solvents. Actual testing is a must for the substrate materials to ensure success in an application. Advantages of designing with PSA: provides structural strength that can replace bolts, rivets, welds, and other mechanical fasteners, permits use of lighter, thinner materials, bond dissimilar materials without incompatibility concerns, acts as moisture seal, environmental barrier, provides vibration damping and noise reduction, shortens assembly time and boosts productivity. Advantages of designing PSAs further are elimination or eliminates the need for a surface re- refinishing to remove weld distortions, etc. Eliminates visible mechanical fasteners for for cosmetic or aesthetic advantages, provides addition to difficult surface like LSE, low surface energy, provides uniform thickness and gap filling properties, eliminates the need for bonding both substrates together at the same time and location, providing optimum maximum flexibility, provides properties and functionalities beyond joining, sound and vibration damping, thermal conductivity, anti-friction or abrasion resistance, flame retardancy, etc. For more information, contact us on our email or join us on our YouTube channel. Thanking you very much.